Let me start my presentation. My name is Hyunhee Chung, and I'm an applied research scientist at SOCAR, the largest cultural platform in Republic of Korea. I will briefly introduce our paper entitled Is Meta-Learning Always Necessary? I will start with the background of our study. Also, deep neural networks have accomplished significant performance in various machine learning applications. There comes the hardship regarding the following question. What if the machine learning practitioners solve a novel task where significant samples are not accessible? And we denoted this problem as novel task problem. In the real world, machine learning practitioners frequently encounter a novel task in which they cannot acquire sufficient non-annotated samples shortly. One presumable approach is dividing the problem into two stages, early stage and mature stage. An early stage describes a circumstance where the machine learning practitioner cannot acquire sufficient samples in the database, but only have a few labeled ones. Label stage, mature stage implies that the unlabeled database includes a particular number of novel particular resources in the annotated procedures. However, the conventional labeling procedures unfortunately have several limitations. First, the machine learning practitioners cannot know whether the pre-labeling dataset includes a target labels or not a priori. Among the recent studies on meta-learning, one examined that supervised representation power on the training set can outperform existing meta-learners. Motivated by this work, we propose a practical machine learning framework to solve the novel task with the supervised learners instead of meta-learnings. We are going to start with the first research question. Does the meta-learner always outperform the supervised learner? Refer to the below two tables. We discovered that the previous study's proposition is valid on their experiment settings as the supervised learner accomplished the best performance on the minimally shifted dataset at both one-shot and five-shot settings. We analyzed that this result implies the effectiveness of supervised representation power over the others. Next, we analyzed that what drives a good representation that we checked in research question 1. We resulted in that contextual representation at the higher layers of the neural network particularly contribute to the effective few-shot classification performance, and these results can be derived from the table 3. Upon the lower layers, the low-level representation of the supervised learner is similar to those of the other learners. We interpret these low-level layers as each learner acquires similar knowledge. Thus, we analyze the lower level features do not seem to be significantly relevant to the supremacy of the supervised learner. And this results from the figure 3 at the right side of the slide. And third, we examined whether we can apply this supervised meta-learning to early stage. Refer to the figure 4, we discovered the supervised learner outperformed other baselines in every problem settings except for three-way one-shot classification at the shape-shifted task. And this is the final slide of our presentation. Finally, with the circumstances of the mature stage that we defined in background section, we figured out supervised learner retrieves the largest number of relevant samples from the pool. Regardless of the similar estimation method and target labels, the supervised learner outperformed the image-retrieval performance rather than other learners. Thus, we validated that the supervised learner always can be applied in zero-shot image retrieval as a major stage solution to the novel task problem. And that's all I prepared. Thank you for your listening.